Hi, Tom the Professor here. It's time for another problem. Let's get started. How about a kinematics problem for this episode? I'll put the text on the screen if you want to join in on the fun. Just like last time, we're going to start with what do we know? We're going on a trip and we want our total average speed to be 90 kilometers per hour. But on the first half of the trip, we're only traveling at an average speed of 48 kilometers per hour. What we need to find is what's the average speed on the second half of the trip. Now, we're not given a total distance for the trip, but that's not necessary in order to calculate what our average speed is going to be. Now, you might be thinking, well, this isn't such a tough problem. Can't we just take the average like we normally do? You could measure a distance over a fixed time or a time to move a fixed distance and use an average where you add up the measurements and then divide by the number of measurements you've taken. But that's only measuring a single metric, a single measurement at a time. Speed measures both distance and time simultaneously, so we can't find an average in the same way. What we need to do is use the equation we have for average speed, which would be the distance traveled divided by the time it takes to travel that distance. Now, in this particular problem, I'm going to set up the distance traveled to be 2d, twice d. Now, that will make sense later on when we start manipulating the equations, why I chose 2d for the total distance instead of just d. What we need to find then is the time to travel for each half of the trip. And we're going to do that by just rearranging this equation for time. Time is the distance you travel divided by the speed you're going. So the time for the first half will be d, which is half of 2d, divided by 48 kilometers per hour. For the second half, we will have distance d, which is, again, half of the 2d, divided by the speed that we're going the second half, and that's the answer we want to find to solve this problem. So we don't know what that value is yet. To get the total time to travel, the total distance 2d, what we're going to do is add up the two times that we just found. So we'll take the d plus 40, or the d over 48 for the first half, and we'll add to that the d over the velocity v, or the d over the speed for the second half. Add those two together, that gives us our total time to travel that we'll put in our equation. Now, when we do that, it's going to look messy. It looks like this. 2d over that fraction plus another fraction. It's a very complex fraction. What I'm going to do is step through the math in kind of quick succession just to get out that final value of v. The first thing I will do is in the bottom there's a d over 48 plus d over v. I'm going to factor out that d. So, and then that will cancel with the top because then we just have a multiplication there. The average speed I'm going to throw in is 90 kilometers an hour. That was given to us. And then it's just a matter of rearranging the equation. So I'm going to take the bracket and move it to the other side of the equation and then divide both sides by 90. And we get this next expression. 1 over 48 plus 1 over the speed that we're looking for is equal to 2 over 90. The 2 comes from above where we had the 2d. And the 90 is the 90 kilometers per hour, which was our average speed. This is sort of the fastest way to simplify this equation. It's not the way you're shown in math class how to simplify this equation, but it's a lot less scary doing it this way. Let me say it that way. Okay, solve for the 1 over v. So we simply subtract from both sides the 1 over the 48. Get a common denominator, which is 720. And then we are left with, once we do that subtraction, 1 over the speed we're looking for is equal to 1 over 720. Reciprocate both sides and we have our answer. 720 kilometers per hour. 720 kilometers per hour. That seems an outrageous number to me. Airplanes fly about, that fast. Can this possibly be the right answer? Well, let's dig a little deeper here. Now, again, they didn't give us a total distance that we're traveling in this particular problem because it doesn't matter. We canceled out that d that I used in the numerator. So let's just pick a different distance. Let's say I'm going to travel a distance of 90 kilometers. This will make the math easier. And I want to use an average speed of 90 kilometers per hour. Maybe you have the answer in your head already, but let's step through it. The time to travel that will be the distance you travel divided by the speed you're traveling at. So 90 kilometer distance divided by 90 kilometers per hour gives you 1 hour. So we want to have an average speed of 90 kilometers per hour in this particular problem. That's what we're given. So that means we have to complete the trip of 90 kilometers in an hour. Okay. Now, if we use a different value here for the distance, like we use twice that distance, 180 kilometers, then we get a value of 2 hours that we have the time to work with. Okay. So we have an hour to work with. Let's see what happens for the first half of that. Now recall, in this particular problem, we're told that the average speed for the first half of the trip will be 48 kilometers per hour. So the time it takes to travel that first half will be half the distance, 45 kilometers, divided by our average speed of 48 kilometers per hour, which gives us a value of 56.25 minutes in order to complete the first half of the trip. Okay, now look back to the previous. We had an hour to do. We had an hour to work with, and we've used up 56 and a little bit more minutes. That means we have 3 3/4 minutes remaining in order to travel the rest of the 90 kilometers. Does that make sense? Okay, remember, we only got that hour to work with, so what we use in the first half plus what we use in the second half has to equal an hour in this particular version of the problem. So let's take a look here. If we are going to then use the 3.75 minutes to complete the second half, we'll still calculate the time, let's calculate the speed that we need to travel at in the second half in order to get done in 3.75 minutes. So the second half speed will be the distance divided by the time it takes to travel that distance. So again, it's 45 kilometers for the second half of the trip. And if you convert the 3.75 minutes into hours so that we have a unit of kilometers per hour, we get 0.0625 hours to complete the second half of the trip. You do that division, and again, we get a speed of 720 kilometers per hour. Okay, we verified the answer. It's the same thing. Now, if you want, so that's all there is to this particular problem. If you want to try out some different distances, go ahead and do that. You can do it the same way I just did. Pick your favorite distance. Use the 48 kilometers per hour to find the time for the first half, and then use that to calculate the speed. And you should get the same speed each time within a rounding error, depending on how many decimal places you keep with some of those fractions you're going to come up with for the time for the first half. So that's it. If you liked it, remember, like and subscribe. Each subscription and like helps me support this channel and gets it out further into the YouTube stratosphere. If you want to leave me a message, hit me up on the social medias at the handle on the screen there. A lot of other work goes into tomteacheспhysics.com, where I keep a blog and some other information. Check out the merch. I gotta mention the merch each time because the merch helps to pay for all the stuff that I do on the blog, on the social medias, on the YouTube channel, even though having a YouTube channel doesn't cost much. But it also helps me support it so that I have the time to do these things. So check out that merch. Pick up something. Take a picture. Send it to me on the social medias, and I'll share it with the world. Until next time, I'll see you next time.